Now, interior of the earth. So, the sources for studying the interior of the earth, we have direct sources directly which are available, and indirect sources which are not available directly. Right. So, direct sources and indirect sources. Surface rocks. So, to study the interior of the earth, we need to study about a rock which is present at the surface. And the rock are having certain minerals, surface rocks and minerals. Deep ocean drilling. We need to do ocean drilling and volcanic eruptions. These are the direct sources. So the direct sources include the rocks which are present at the surface, rocks, and we are going to go for drilling. This is deep ocean drilling, and once ocean drilling is being completed, we also have the volcano eruption. Volcanic eruptions are direct sources. So volcanic eruption are direct sources. Then we have the indirect sources. Indirect sources is density studies. So density studies related to the indirect sources and seismic studies. The density, earthquake studies, and temperature and pressure studies. Temperature, pressure, density, and even meteorite is an indirect source over here. So, density, temperature, pressure, and then we have the seismic studies. Density, temperature, pressure, then we have the seismic studies. After the seismic study, we have the temperature and we have the meteorites. Earthquake and then meteorite. Earthquake and meteorite. So meteoroid is when it escapes the asteroid belt. Meteor is when it enters the earth's atmosphere and catches fire. Meteorite is when it touches the surface of the earth, right? When it hits the surface of the earth, it is meteorite. So meteorite, it is right. We have to Indirect sources include density, temperature, pressure, and earthquake, seismic, and meteorite. Now, direct sources is going to include the first one is the rocks, which are at the surface, and volcanic eruptions. The third one is deep ocean drilling. You have to drill the ocean, right? Oceans are already in the lower portion because oceanic crust is heavier and it is at the bottom, whereas continental crust is floating. So oceans are already in the lower portion. Now we could go only up to 12 kilometer, but the center of the earth is 6370 kilometer. We could reach only up to 12 kilometer, right? The center of the earth is 6370 kilometers. There is very high temperature, and then we have the pressure. Now density studies, mathematical. Now we know the surface rocks which consist of minerals, right? And we also know the volcanic eruptions. Now in deep ocean drilling, they are already in a lower portion. We say that they are already at a lower portion. They are already at a lower portion. Deep ocean drilling is they are already at a lower portion. So when we are going for the deep ocean to get the material, we could go only up to the 12 kilometer. We are going only up to the 12 kilometer. The center of the earth is 6370 kilometers. So the center of the earth is 6370 kilometers. We have very high. So here we have very high pressure and temperature. So we'll be having the very high pressure and temperatures. Now, in indirect studies, density studies, temperature pressure studies, seismic studies, and meteorite studies. In the direct studies, we have the surface rocks, volcanic eruptions, deep ocean drilling. In the indirect studies, the density studies, mathematical studies, we need to know mathematical studies. By using the gravity, we can calculate the mass. We can have the volume of the earth. Density is equal to mass by volume. The surface density is 5.5 gram per centimeter square, whereas this is average density. The average density is 5. 5.5 gram per centimeter square. Mass is gram and volume is centimeter cube. Sorry, centimeter cube. So the average density is 5.5 gram per centimeter cube. The density at the surface density is 2.7 gram. So 2.7 gram per centimeter cube. So the average density is 5.5 and surface density is 2.723. 2.723 average density versus the surface density. So average density versus the surface density, and then we have the center density. The center is having a density of 13 gram. The center is having a density of 13 gram per centimeter cube. By using the gravity, we can calculate the mass is calculated with the help of the gravity. We already have the volume of the earth. So by using the gravity, we are calculating the average density is 5.5 gram per centimeter cube. Whereas we have the surface density is 2.723 is the surface density, and the center density, the density at the center is 13 gram per centimeter cube. So the center density is 13 gram per centimeter cube. Earthquakes is releases the earthquake wave in all the directions. Collect the earthquake wave and we need to study. All the waves originate at the same speed. Later they acquire different speed and directions because of different layers found on the earth. So all the waves, when they are originating, they are at the same speed. But later they are having different speed at different speed and different directions. This is because of different layers, different speed and different directions. This is because of different layers. The different layers is found on the earth. So different layers found on the earth. We studied about the density studies, and seismic studies is related to earthquake, temperature and pressure, meteorites, right? So the density studies, we say that the density is equal to mass by volume. Gravity is used to find the mass, and we have the volume of the earth. So the average density is 5.5 gram per centimeter cube. The surface density is 2.7 to 3 gram per centimeter cube, whereas the center's density is 13 gram per centimeter cube. Now we have the earthquakes. The earthquake waves are released at all the directions. Collect the earthquake waves and we need to study. The waves originate at the same speed. Later it has different speed and direction because of different layers found on the earth. Volume is nothing but the space. So here we are, a man is occupying half of the volume of this box. But if the box's size is increased, the man is occupying half of the volume, right? The man is occupying just one third of the volume over here. So mass volume varies, but mass remains constant. Volume is the space occupied, whereas mass is the measure of all the matter that makes an object. All the matter, it is all the matter that makes an object. So we have all the matter that makes up an object. Volume is going to be the space it occupies, whereas the mass is all the matter that occupies an object. All the matter that occupies the object. So volume is the space it occupies, whereas mass is the matter, all the matter that makes up the object. We have asthenosphere, where it is the source of the magma for the volcanoes. So what is the source of magma? Source of the magma. So we have to know the source of the magma for the volcanoes. The source of magma for the volcanoes is asthenosphere. Asthenosphere is the source of magma for the volcanoes. Radioactive element, it is liquid. High temperature. The temperature and pressure studies. We have temperature and then we also have the pressure studies, right? When we are digging 32 kilometers, the temperature increases by 1 degree Celsius. When we dig for every 32 meters, the temperature increases by 1 degree Celsius. So at the center, it is 6,500 kilometer, right? So the temperature must be 5,200 degrees Celsius, the core temperature. But according to this formula, the temperature must be high. The Earth center is approximately the center of the Earth is 6,370 kilometers. For 32 meter itself, we have 1 degree Celsius. 1 kilometer is 1000 meter, right? Now, when you convert this into meters, 6370000 meters. When you divide it by 32 for 1, you are going for 1 degree Celsius, it is greater than 5200 degrees Celsius. So 5200 degrees Celsius is the temperature of the core, right? So when you divide this by 32 per degree, right? So 32 meter per degree, then the core temperature must be higher. Now what is the core temperature? When it is divided into 637 and 4 zeros, the core temperature must be approximately 2 lakh degrees Celsius, but it is just 5200 degrees Celsius, the core temperature. Therefore, here pressure acts. The correlation between temperature and then we have the pressure. With higher pressure in the Earth's atmosphere, the rate of increase is decreasing. It does not increase as per 32 degrees Celsius, 32 meter per Celsius. The rate of increase of the temperature is decreasing. Right. So the rate of increasing of the temperature is decreasing because with the high temperature, high pressure, because of the high pressure in the Earth's atmosphere. So we have the high pressure. High pressure, the rate of increase of the temperature has been decreased. Therefore, this is the correlation between temperature and the pressure. What is a meteorite? From the outer space, they are made up of same material as the Earth from nebular hypothesis of Laplace. Nebular hypothesis is finding its way in many places. Core is made up of iron and nickel. The core is made up of iron and nickel. Similarly, the meteorite is having a core which is made up of iron and then we have the nickel. From the outer space, they are made up of the same material as the Earth, is what we have the nebular hypothesis. Interior of the Earth. Now, this is the answer. The sources of study of the interior of the Earth is direct sources or deep ocean drilling. Provides the information about the interior by extracting the material from the Earth's interior. We have drilled up to 12 kilometer. Volcanic eruptions. Magma from the interior of the Earth can be studied to reveal the information regarding the composition, temperature, etc. 50, 150 or 200 kilometer interior magma comes out. The magma comes out from asthenosphere. Indirect sources is density studies. By analyzing the average density of the Earth and comparing it with the surface density, we can conclude that the core must be heavier because the core is 13 gram per centimeter cube, whereas the average density is 5.5 gram per centimeter cube. And the density of surface, average density and surface density. The density of the surface is 2.7 to 3 gram per centimeter cube. Core is 13 gram per centimeter cube. Seismic studies involve the different earthquake waves and the changes in their direction and speed as they pass through the interior. Temperature and pressure studies. It involves the study of variation in the temperature as we go deeper into the Earth's interior after considering the effect of high pressure. We have high pressure. It involves the study of variation. So we'll be having that it involves the study of variation in the temperature as we go deeper into the earth. After considering the effect on the pressure near the surface, the temperature increases at the rate of 1 degree for every 32 meters. However, the temperature in the core is estimated to be 5300 degrees Celsius. Temperature is high due to the chemical reactions under high pressure conditions and disintegration of radioactive elements. Meteorites are of same material as the Earth. The chemistry and mineralogy of nickel and iron core of meteorites provide information of the Earth's interior. Now, the Earth's division, the first is two types of divisions. There is a chemical division and there is a physical division. Okay. Now, what does the Earth is made up of? The first thing is there is a crust, and then we have the mantle, inner core, outer core. So this is the crust, and then we have a mantle, inner core, outer core. Sorry, outer core, inner core. Crust, mantle. This is inner core and this is outer core. Crust is the outer shell of the earth. It is nothing but a shell of the earth, and it is very very thin. 1% of the volume alone is crust. Mantle is 84% of the earth's volume and 68% of the mass. Mass is what it is made up of, what matter it is made up of, right? Mantle is the space it has occupied. Sorry, volume is the space it has occupied. So the volume, it has occupied 84% of the space and 68% of the mass. Crust is occupying only a very outer shell. It is just like a shell of the egg. The shell of the egg is very very thin, just 1%, right? 1% of the volume, right? The similar is also for the crust. Crust is the outer shell of the earth. So we have the crust as the outer shell of the earth. It is very very thin and it is 1% of the volume. It is 1% of the volume. Crust is the outer shell. So we'll be having the outer shell of the earth. Right. It is 1% of the volume. Mantle is having like 84% of the volume and 68% of the mass. Core is having, just subtract from it, 1% of the volume is crust. 84% of the volume is mantle. The remaining 15% of the volume, this is related to the volume, is 15% is what we have the core. Then we have the mass. So 68%. The remaining is 32%, but crust is having 1% of the mass as well. Right, so 31% is the mass of the core and 15% is the volume of the core. 15% volume, so mass is very high, therefore it is very densely packed. This is the physical divisions, sorry, chemical division. It is based on the chemical composition. For chemical division of the earth, we are going for the crust, mantle, core, CMC. Crust, mantle, and then we have the core. This is a chemical division, is what we call it as a crust, mantle, and core. For physical division, we are going for the lithosphere, asthenosphere, then mesosphere, barysphere, lithosphere, asthenosphere, mesosphere, and then we have the barysphere. Crust is the outermost layer and it is the lightest among all. Right. For physical division, we are going for the lithosphere, asthenosphere, mesosphere, barysphere. Now in the chemical division, we have the crust. This is 1% of the earth's volume and 1% of the earth's mass. It is very thin and brittle, means like the eggshell, how it is breaking, right? It is brittle. The density increases as we go towards the core. The density of the crust is 2.7 to 3 gram per centimeter cube. So the density is 2.7 to 3 gram per centimeter cube. Crust, mantle, and then we have the core. The crust is of two types. continental crust and oceanic crust, right? The crust is of two types. That is why we say 2.7 to 3, right? 2.7 is continental crust and 3 is oceanic crust. So 2.7 is continental crust and then 3 is the oceanic crust. From below the water, we have the continental crust is lighter and the oceanic crust is heavier, denser. Continental crust and then we have the oceanic crust. Continental. So this is the physical divisions, right? So this is the physical division is continental crust and oceanic crust is the physical division. Now we go for lithosphere, asthenosphere, mesosphere and barysphere is the physical divisions. The physical division is nothing but the lithosphere. Lithosphere, asthenosphere. So lithosphere, asthenosphere, mesosphere and barysphere is a physical division. We have the chemical divisions is the crust, mantle and the core. We have the crust, right? So the crust is 1% of the volume and as well as 1% of the mass. It is a very thin and it is brittle. Very thin and it is brittle. The density of the crust is 2.7 in case of continental crust and 3 in case of the oceanic crust. Along the landmass there are very thick crust. 2.7 gram per centimeter cube is the density, surface density of the continental crust, and then we have the oceanic crust is below the water. Continental crust is lighter and it is 2.7 gram per centimeter cube, whereas the oceanic crust is heavier, which is 3 gram per centimeter cube. Continental crust is composed of Sial and oceanic crust is composed of the Sima. Silica and aluminum is continental crust. Silica and magnesium is oceanic crust. Because of the components, it is brighter in color, it is darker in color. Because of lighter components like silica and aluminum, it is lighter, dark, brighter in color, and here it is darker in color. It is thick up to, it is very thick, it is thick, thinner. 35 to 40 kilometers in case of an average 45 kilometer, and mountains are 60 to 70 kilometer, right? So the continental crust are thicker. From here itself the thickness you can tell that the continental crust are thicker. So 35 to 40 kilometer is in the case of normal continental crust, and then we have the mountains. We have 60 to 70 kilometers is for mountains. We have the 60 to 70 kilometer. So continental crust is thicker up to 35 to 45 kilometer is the continental crust thickness, and the mountains are having 60 to 70 kilometer is the mountains. Continental crust and then we have the mountains, right? Now oceanic crust is heavier in the density is 3 gram per centimeter cube. Composition is Sima is going to be silica and then we have the magnesium. It is darker in color, the oceanic rocks. Thinner is maximum of 8 to 10 kilometers. The thickness is 8 to 10 kilometers, therefore it is thinner when compared to continental crust of 35 to 45 kilometer normally, and in mountains it is 60 to 70 kilometer. The continental crust, it is made up more of lava, and the oceanic crust is magma. It is older. The continental crust never gets destroyed, but the younger, because the oceanic crust is continuously destroyed and created. Other elements are sodium and potassium. Granite is from continental crust, and basalt is from the oceanic crust. Granite is from the continental crust, and then we have the basalt is from the oceanic crust, right? So the granite is from the continental crust and basalt is from the oceanic crust. Now we are going for the mantle. 84% of the volume, and then we have 68% of the mass. 84% of the volume. 84% is the volume and 68% is the mass. The second layer in the Earth's interior. Crust, mantle core with respect to thickness. The depth of the mantle is 2888 kilometer. The rocks fully on the top except the top layer is viscous. So we have the upper mantle and then we have the lower mantle as well. So lower mantle, the rocks, it is full of rocks, so it is 2,888 kilometer. It is full of rocks except for the upper layer which is viscous. Mantle is of two types. First is going to be the upper mantle and then we have the lower mantle. The main component is increase in the magnesium. Now we have lesser iron and aluminium, increase in the magnesium, mix of the crust and then we have the core. So from the crust it takes magnesium, from the core it takes the iron, right? Magnesium and aluminium are lesser in, aluminium and iron are lesser in uh, composition. The density of the mantle is 3.4 gram per centimeter cube. Oceanic, continental. The density of the mantle is 3.4 gram per centimeter cube. Now here itself, when we are dealing with the mantle, it is having less content of iron and magnesium. Iron and magnesium, but it less content of iron and aluminium. Now silica, aluminium, magnesium, aluminium, magnesium, iron and nickel. Now once again, when we are going for the mantle, it states that mantle is 84. We have mantle is 84% of the volume is mantle and 68% of the mass is the mantle. So 84% is the volume and 68% is the mass. It's a second layer and the heaviness is crust, mantle and core. So the thickness density is 3.4 gram per centimeter cube is the density. The depth is 2888 kilometer is the depth. The rocks, fully rocks except the top layer which is viscous. Mantle is of two types, the lower mantle and then we have the upper mantle. The main component is increase in the magnesium, lesser iron and aluminium, mix of crust and core. The density is 3.4 gram per centimeter cube. Now the core is 15% of the volume, Earth's volume. Like we already said that 84% of the Earth's volume is mantle and volume. This is, and 1% is crust. These are chemical division of the earth, right? Crust, mantle and the core are chemical divisions of the earth. The core is 15% of the earth's volume, the innermost layer of the inner earth's interior, heaviest in terms of the density. Mainly it is consists of the nickel and then we have the iron. Nickel and iron density is 13 gram per centimeter cube, whereas the density of the continental crust, density of the oceanic crust, and the density 3.4 is the density of the mantle, and core is having a density of 13 gram per centimeter cube. Core mantle is having a boundary of density of 5.5 gram per centimeter cube. So we have the core and the mantle boundary density of 5.5 gram per centimeter cube. Boundary is having 5.5 gram, average is 5, right? So the boundary between the core and the mantle is having 5.5 gram per centimeter cube. Core, asthenosphere, mesosphere and barysphere. The chemical divisions are the crust, continental and oceanic crust, mantle, and then we have the core. These are chemical divisions. The physical divisions are lithosphere, asthenosphere, mesosphere, barysphere. We are not even speaking about core, mantle, right? Lithosphere is, first we'll be having the continental crust, then oceanic crust. So continental crust and oceanic crust, this is how the differentiation has been done. Continental crust, oceanic crust. Asthenosphere, and then we have the oceanic crust, upper mantle, asthenosphere, and then we have the lower mantle. Upper mantle, asthenosphere and lower mantle. Continental crust, oceanic crust. Then we have continental crust, oceanic crust. Then we have the upper mantle, and then between the upper mantle and the lower mantle, we have the asthenosphere. Outer core, and then we have the physical divisions of the Earth include lithosphere, asthenosphere, mesosphere, and barysphere. Lithosphere is divided into the continental crust and oceanic crust. Asthenosphere. So now upper mantle, there is a mantle, asthenosphere, and then we have the lower mantle, asthenosphere, and then we have the lower mantle. So lithosphere is nothing but the continental crust plus the upper part of the upper mantle is what we have the lithosphere. The uppermost part of the upper mantle is the lithosphere. After that, asthenosphere is 660 kilometer. Lower mantle. The total length of the mantle is 2888 kilometer. The core, when we are reaching till the core, it is 6371 kilometer. So 6371 kilometer. We have the outer core and then the inner core, right? The outer core is going to be like the outer core is going to be 2270 kilometer, and the inner core is going to be 1216 kilometer, 1216 kilometer. The inner core is a solid iron, and the outer core is 2270 kilometer, 1216, 2270, 1216, and then we have 2270. 1260 kilometer and 2270 kilometer. So we have the 1216 kilometer, and then we have the 2270 kilometer, 70 kilometer. So 1216, and then we have the 2217. Now we have the crust, right? The crust and then the uppermost portion of the upper mantle is what we call it as a lithosphere. The crust is approximately 50 kilometer, whereas the lithosphere is 100 kilometer. Asthenosphere until mesosphere is what we have the mantle. Core is barysphere. This is the chemical and this is the physical. Lithosphere, asthenosphere, mesosphere, barysphere. Crust plus the upper part of the upper mantle is 100 kilometer. Upper part of the upper mantle is 100 kilometer. That is some part of the upper mantle. The lithosphere plus asthenosphere is the upper mantle. So we have the lithosphere plus the asthenosphere is what we have the upper mantle, right? Mesosphere is the lower mantle. Mesosphere is entirely the lower mantle. Now upper mantle is 700 kilometer and lower mantle is 700 to 2900 kilometer. The upper part of the upper mantle is attached to the crust as it moves together as a single unit in the outer movement. Lithosphere is not static, it moves. Plate is broken part of the lithosphere, right? The upper part of the upper mantle, that is the it is attached to the crust and it moves as a single unit in the outer movement. So the upper part of upper mantle, in the upper mantle itself, the upper part is attached to the crust and it moves as a single unit. The lithosphere is not static and it moves. The plates are broken part of the lithosphere. So 100 to 400 kilometer is the asthenosphere is 660 kilometer. A mantle is total 62880. Outer core is we be having 2000, right? 2270. 1216 is the inner core. Crust, lithosphere, mesosphere is solid. The rest of the mantle. Asthenosphere is plastic. It is totally liquid. It is not totally liquid or not totally solid. It is plastic. So it is not totally liquid and it is not totally solid. It is plastic. So asthenosphere is plastic in nature. It flows under the pressure. It is little viscous. It is flowing under the pressure. It is only little viscous. So asthenosphere is not totally solid or not totally liquid. It is plastic. So the state of asthenosphere is plastic. It flows under the pressure and it is little viscous. It is a zone of magma generation. Asthenosphere is the zone of the magma generation. So we have asthenosphere, and asthenosphere is a zone of the magma generation and it comes through volcano. When earthquake waves pass through this layer, its speed decreases. Therefore, it is called as a low velocity zone. So since it is plastic in nature, the earthquake waves passes only through the solid, right? P waves pass only through the solid. Sorry, X waves pass only through the solid. It is not totally solid and not totally liquid. Since it is plastic, it decreases the speed of the earthquake waves. Therefore, it is called as low velocity zone. Asthenosphere is called as a low velocity zone. So we have the asthenosphere as a low velocity zone. It is not totally solid, not totally liquid. It is plastic. It flows under the pressure and it is little viscous. It is a zone of the magma creation. It comes through the volcano. It comes out through the volcano when the earthquake waves is going to pass through this layer. Its speed decreases. The core is made up of barysphere. The physical divisions is going to be the lithosphere is the outermost solid layer which is made up of the crust, and then we have the upper part of upper mantle, right? So the lithosphere we know that it is a solid layer. It is a solid layer which is made up of the crust and the upper part of the upper mantle. It is divided into the 10 different plates. The thickness of the lithosphere is up to 10 kilometers. Sorry, 100 kilometers. Asthenosphere is plastic and less viscous. It is between 100 to 400 kilometers. It is a source of magma and it is a low velocity zone. Mesosphere is the rest of the mantle. Barysphere is inner core and outer core. The major elements of the Earth's crust is first is oxygen is a major element. By weight, it is 46%. The crust. Then we have silicon only at the crust, right? Then we have the silicon is 27.72. Aluminium, iron, calcium. So oxygen, silicon, aluminium, iron, calcium. O psi C. Oxygen, silicon, aluminium, iron, calcium. This is the Earth's crust is going to have oxygen, silica, aluminium, iron, calcium. But the entire Earth is going to have, the entire Earth is first iron, oxygen, silicon, IOS, right? Magnesium, nickel. So we have then magnesium and then we have the nickel. So IOS is iron, oxygen, silica. This is O psi C. O psi C. Oxygen, silica, aluminium, iron, and calcium. But this is different. It is IOS Mn, iron, oxygen, silica, magnesium, and nickel. This is the entire elements which is present in the earth. The elements, right? Not gases. So the elements in the crust just begins with the oxygen and silica, aluminium, iron, and calcium. The elements in the entire earth is IOS Mn, iron, oxygen, silica, magnesium, nickel. Oxygen, it is not a gas, it is the oxide of various elements. Then there are various discontinuities, the layers where difference in characteristics are appearing to be very contrast. It is a transition zone between the different layers of the Earth's interior with different physical and chemical characteristics. There are in total 5 discontinuities between upper crust and then the lower crust. Between the crust and the crust, between the lower crust and then we have the mantle between, so we call it as a crust and the mantle. Crust and crust, mantle, crust and the mantle, crust and crust, crust and the mantle, mantle and mantle, mantle and core, core and core. 1 2 3 4 5. Crust and the crusts, we be having the crusts, right? Conrad discontinuity. And then we have the crust and the mantle is Moho discontinuity. Mohorovic discontinuity. That is what we call it as Moho discontinuity, right? Between crust and the crust, we have the Conrad discontinuity. So between the crust and the crust, we'll be having the Conrad discontinuity and Mohorovic discontinuity is between the crust and the mantle. We have the Mohorovic discontinuity. Between the mantles, we have repetitive discontinuities. M and M is repeating, right? So M and M is repeating, right? Repetitive discontinuity. Repetitive discontinuity. Then between the lower mantle and then the outer core is Gutenberg discontinuity and then Lehman GL Gutenberg discontinuity and Lehman discontinuity. Discontinuity refers to the change in the speed and change because of the change in the discontinuity, the speed of the waves is going to changes. So first we'll be having the CC, right? CC is Conrad discontinuity. Between the crust and the mantle, we'll be having the Mohorovic discontinuity. Between the mantles, we have repetitive discontinuity. Then GL, and between the mantle and the outer core, we'll be having the Gutenberg discontinuity. Gutenberg discontinuity. Between the cores, we'll be having the Lehman discontinuity is between the core. It refers to the changes in the speed, changes in the density. Lithosphere, asthenosphere and mesosphere, barysphere. We have the conventional currents, right? The conventional currents are in the upper core. Due to temperature and then the pressure, the outer core magma is going to of the outer core. Temperature and pressure of the outer core, the magma in the inner core, it is going to iron core, right? Here the magma is going to have a convectional current.